Hi everyone, welcome to the day 2 of API Days Hong Kong 2021. I'm Satya and I'll be hosting stage 2 on API product and community, and we have 3 interesting talks in our first segment this morning. Please welcome Damir Svrtan from San Francisco, senior software engineer at Netflix. He's a conference speaker, technical writer, open source lover and contributor. Hi Damir, how are you today?
Hi, pretty good. Thank you.
Wonderful. Excited to have you here this morning.
Thank you.
Damir is going to talk about building customer-centric APIs, which has just enough data and explains on how to design minimal APIs that are straightforward to use under the title Less Data is More. Are you ready, Damir?
Absolutely.
Wonderful. Over to you.
Awesome. Thank you. Hi, folks. My name is Damir, and I'm going to be talking about designing APIs or when less data is more. I'm super glad I could present to you all today. I'm sad that we're not all together at a nice location where, we could all meet up, but at the same time, it's great that we could all join this conference from across the globe. Let me introduce myself. So my name is Damir Svrtan. My pronouns are he, him, and I work as a senior software engineer at Netflix. I'm based in San Francisco, and that's where I moved about 3 years ago. I'm giving you this presentation from my home in San Francisco, and here with me is my dog, Masha. Now, prior to moving to San Francisco, I used to live in Zagreb, the capital city of Croatia, a small country in southeastern Europe. That's where I grew up and spent the first 28 years of my life. Now, designing APIs, less data is more. Why is this topic relevant to me? Well, I've been building APIs for the last 7 years, and I've seen a pattern where developers like to expose more data than is actually needed. I want to talk about avoiding overhead when designing APIs. Now, what kind of overhead? Well, I want to talk about not building bloated, overly flexible APIs. Examples of those might be queries that nobody asked for, endpoints that nobody's using, generally unused functionality like extra fields or extra relationships on resources, all of these things that nobody probably asked for, but you still have to maintain. Now, what kind of APIs am I going to be talking about? Mostly about HTTP-based APIs. Those are kind of what I've been building in the last many years. This is applicable for REST APIs, JSON APIs, GraphQL, etc. But in general, it's going to be API technology agnostic. It's going to be applicable for all kinds of APIs. Now, through this talk, we're going to be building a blogging platform, something similar to Medium or to Dev2. Now, it's going to be a fairly simple blogging platform. It's going to have only a couple of features like authors that can release posts and posts that can have comments. So pretty simple. Now, I'm going to be talking through this through 2 principles for building APIs. The first one being designing the minimal API surface, or how not to overexpose data on your APIs. And then the second one, designing from strict to loose, or how to avoid building extra flexibility that nobody asked for. Generally, I see a pattern where developers try to be speculative about what's going to be needed in the future, so they often overbuild their APIs. So the first principle is going to be designing the minimal API surface. I'm going to break this into 3 patterns of a bloated surface that I usually see. The first one being redundant fields, the second one redundant relationships, and the third one redundant input fields. So let's start with not exposing redundant fields. Now, let's imagine we're building this blogging platform and we get a requirement from our product manager that says we need to show the author of the blog post. I took this screenshot from medium.com, so it's, a lot of you might be familiar with that. So let's say we have an authors table in our database, and it's got an ID, a first name, a last name, an email, and an avatar. Now, if we look at the design that we got, we have the avatar, we have the first name, we have the last name. We might need to use the ID for, some kind of client-side caching. There's no email whatsoever here. Now, the friendly API developer that's maybe working on this product might say, let's expose the email. Somebody might find it useful in the future. Why wouldn't we expose the email field right away? We're going to spend more time exposing it if we need it afterwards, right? So we're technically saving time for the business. So the friendly API developer, writes in the schema descriptor of whatever sorts the developer has and puts in an email. And now let's imagine 6 months later, for privacy reasons, we need to stop exposing the email. And I'm not making this up. There's various privacy laws across all of the world, like Europe has GDPR, California has its privacy laws. There's privacy laws all over the place. And a lot of them dictate that if you're not using the data, or if it's not valuable, you're not supposed to, or if it's not valuable for the product, you really shouldn't be exposing that data. Now, what does the friendly API developer need to do now? They need to mark the field as deprecated. If there's API schema descriptors, allow for that. Or if it's some kind of a versioned API, maybe they need to expose another version. It's a lot of work. And then there's extreme amounts of communication, emails, reaching out to clients and consumers. If we're building a platform, this can be really hard. Like, we need to give a few months of lead time and communicate a lot. If it's a private API, there might be a smaller amount of clients, but a lot of communication nevertheless. And then we're potentially breaking clients. Like, if we have some kind of API, then whenever you ask for an author, it always gives you all the fields. You don't have any idea whether you're breaking clients technically or not. If you have something like sparse field sets in the JSON API specification, or maybe like field selectors in GraphQL, you really better have metrics and observability around that so that you know that nobody's asking for this field. And then there's extreme amounts of redundant cycles. There's multiple deploys. There's deploys that you have to do to mark the schema descriptors, in the schema description that the field is deprecated. You need to deploy the test or staging environment. You need to test it out, make sure nobody's complaining, and then eventually you roll it out to production and really cross your fingers that you didn't break any client. So it's not just as easy as removing a few lines of code. The technical execution of it is really simple. Anyone can do that, but like the amount of communication you have to do and amount of redundant cycles is really the painful part. Okay, so that was about not exposing redundant fields. Let's talk about not exposing redundant relationships, which is relatively similar. So let's imagine we have a requirement that says we need to indicate whether a post was reviewed. So let's imagine our blogging platform is building this feature where we have some kind of group of reviewers, maybe academic reviewers, that are gonna, mark certain posts as reviewed. And we're gonna maybe show like a little green check mark next to the blog post title that just says that this has been reviewed. Now, if in our schema descriptors we have this post type that has a title of the post and just the body, really simple. And what we need to add is just a reviewed Boolean. So just so that our consumers know whether it's true or false. Very simple. But now back to our friendly API developer, who might say, let's expose the reviewer for future use cases as well. Not just whether it was reviewed, but who reviewed it as well. So we go ahead and we make this new type called reviewer and add the field to the post. Now, what did we get with this? Now our development costs are growing. We need to, do batch or eager loading or some kind of lazy loading of additional resources, because probably our reviewers and our posts don't sit in kind of like the same document in the database or some same table in the database. We need to test it out to make sure that it's working. And then there's potentially performance impacts. Like, again, if we build our API in a sense that whenever you ask for a post, you also get a reviewer, we're technically paying, performance penalties. So, and what happens if we decide, a few months after, Like our product decides, let's have multiple reviewers per single blog post, and let's actually expose them. Let's put their avatars next to the blog post title. So what did we get with this? Now we have to go again through a deprecation cycle, a lot of communication, emails, Slack messages, etc. And then we're potentially breaking clients again. But then there's one more important thing that we're not utilizing, and that is delaying decisions. Because adding later when we have more knowledge is better. Let's think about it. Like if we add something 6 months or a year afterwards, we will have a better grasp of the system that we're building. So if it's not needed for the product now, it's better to add it later when it's actually needed. We might decide it's not called reviewers, it might be called something else like users, or the type of it might be called users. So there's a variety of things that we're not utilizing here. In general, it's always easier to add in the future than to remove. I've been through this many times where I was removing stuff that nobody asked for, and I guarantee it's way easier to add in the future than it is to remove. Sometimes additions to the API can be done within an hour, while removals take a lot of time. Okay, so that's about exposing fields and queryable resources. Let's talk about not exposing redundant input fields. What kind of input fields am I talking about? Like if you're building GraphQL, that might be the input fields your mutations are getting. But if you're building a REST API, that's the payload your API accepts when you're changing or mutating data. That would be the data your API gets whenever a client initiates a post or a put request. So let's look at an example. We might get a requirement that says readers need to be able to create and update comments. Pretty reasonable for a blogging platform, right? And now let's imagine we have this input that, for creating comments, where we have to send the post ID to which the comment is going to be attached to, and the body. And now the friendly API developer might say, let's have parity between inputs. So the developer might, build the update comment kind of input and, specify the ID, specify the body, but also add the post ID. But well, all that you need is an ID and a body. Why would you need a post ID? Like, are you gonna at any point transition comments from one post to the other? The blogging platform doesn't support comment transitions from one post to the other. Probably I never saw such an implementation anywhere. So why would you then expose this post ID? I would in general say try to avoid anemic data modeling. Sure, the create comment has the post ID. Sure, even the comment resource might have the post ID, but does it mean that we're able to update it? No, these do not have to match. You're supposed to build your apps according to your business needs, and that business logic should be on the server, not on the client. There's a really great article by Mark from GitHub. It's called GraphQL Mutation Design, Anemic Mutations, that kind of dives deeper into this. So I would definitely recommend looking that up. And then ambiguity deteriorates developer experience. Our consumers might be confused. Like, what happens if I send the same value? What happens if I send a different value? What do we do on the server if they send a different value? Do we block the request? And then lastly, you ain't gonna need it. Just don't do it. Just don't add it. Okay, now towards the second principle, strict to loose. There's like two parts of this principle that I want to talk about. First one being avoiding extra flexibility, and the second one, breaks first. Now, avoiding extra flexibility, when you're building your API, what you want to do is be ready for extra flexibility in the future, but not extremely flexible now. You need to scope out what is needed for your clients and build that minimal product. Now, let's say we have a requirement. The users need to be able to see comments on a post, just to list them out. So we might have an endpoint of some kind of a query that's called comments, and it accepts a post ID, and the post ID is required. Now, again, our friendly API developer might say, well, our clients might want to fetch all comments in the future. Let's just enable them to not send that post ID, or let's make it optional. Now, what do we get with this kind of an implementation? We got unneeded application logic. We need to handle both cases, when there is a post ID and when there isn't a post ID. And more code in general means more maintenance. Anytime you change some commenting logic, you need to reflect that in both scenarios. And what about caching? Are you going to have two strategies for each of these? And then more code means more tests, because you got to test both cases out to make sure that your product is working properly. So I would say, in general, on inputs, it's easy to go from required to optional. That's not a breaking change. But the other way around, it is. So strict to loose or required to optional gives you more control. It gives the client less flexibility, but it's not the flexibility they've ever asked for. It gives you more flexibility in terms of changing, while loose to strict is a breaking change. Okay, and now the second part of the second principle, breaks first. I want to talk about defensive programming and ensuring that your API is not going to get abused. Let's go with the same example. We have a requirement, the ability to fetch comments for a post. Now, the friendly API developer might just say, let's just give them an array of comments. We don't need pagination. Or even a better version of this, we don't need pagination yet. Now, the API developer might just, give an array of comments and might think, we won't have more than 5 comments per post. But 6 months later, there's posts with hundreds of comments. I've seen this happen many times where, it's really great if there's like hundreds of comments and you didn't expect that. That probably means your product is getting used really well and you're getting traction, which is awesome. But it's not awesome for the developer that didn't build in pagination. So now the developer might say, let's add pagination. And we introduce some kind of paginated comments. Really doesn't matter what kind of an implementation. But this is potentially either a breaking change or you're introducing a new query like paginated comments. And now all of a sudden you have to maintain code. And now the API developer might say, work is done, let's go home. Well, not so soon. What if the client actually, when they ask for comments, they just say, give me the first 1,000? Because the client was too lazy to actually do paginated requests. So what happened now? The friendly API developer didn't add limits to pagination. Adding pagination limitations from the beginning is the way to go. You can do something like an error message that just says requesting 1,000 records exceeds the first limit of 100 records. It's super hard to add it retroactively, but super easy to adjust in the future. Like if you don't add it at all and you add it afterwards, the limitation itself, that's potentially a breaking change as well. Well, if you start with a really low number, maybe 10, 20, 50, 100, and if there's cases to get, where your consumers might want to get more, you can build that in. You can figure that out easily. Now, how to avoid these overheads and these principles that I've been talking about? First off, I would say adopt schema-first design. Figure out what is your domain and for whom you're building your API. Don't try to play guessing games. Don't couple your APIs to specific implementations. Maybe today you have a relational database that is backing some of this data. Tomorrow it might be some API that won't have the same fields, and you might bring yourself more trouble than anything. And then talk to your clients. Involve them early in the process. Figure out what their needs are. Don't try to be speculative. And be responsive to your clients' requests. As you're building out a minimal schema that is not overbloated, you have to be responsive to feature requests. Now, there's always exceptions to these kind of best practices. One might be if you're building a platform API, and this is very speculative as well, but there might be a little bit of speculation here if you're building a platform and trying to get ahead of competitors and try to drive user adoption. But even then, I would really question how much this kind of speculation is worth it. And then you might have, the other example is if you have constraints due to release cycles. I have a coworker that worked on APIs that were deployed on premises for their clients. And they would release these once every 6 months, and they would have to do thousands of deployments every time they released. And if they missed a field that a client might need, they would have to repeat the same redeployments, which would be extremely costly. Okay, so in conclusion, what I want you to take from this talk: redundant work slows down progress on important features. Instead of adding those extra things and being speculative, you might be able to spend your time more wisely by improving API documentation, improving slow queries, and so on. In general, exposing too much data can be highly unproductive. There's a saying, the road to hell is paved with good intentions. Even though we might think we're doing something good for our API, API clients and being a good partner. In these cases, in these situations, that is not the case. Thank you all. That's it for me. My name is Damir Svrtan again. This is my Twitter handle. I work for Netflix in the studio engineering department. We're hiring across the board. So if you're interested in talking, just hit me up. And in general, if you want to talk more about this topic, let's talk afterwards, or again, reach out to me on Twitter. Thank you all.
Thanks, Damir. Great talk. Just designed for what is needed and not for all unknown use cases. Yeah, pretty much.
Yep.
Great.
Yeah.
So, just a question. So, why do you think teams design large APIs? Does it grow over time? What's your take on it?
Yeah, I think a lot of folks just try to, be speculative or try to future-proof their APIs, or maybe they try to like match their database schema, and that kind of, API design kind of doesn't lead to good products or good API products. But again, I think a lot of engineers also try to be helpful. If you're building something with like a front-end team and you're thinking, yeah, well, they might need it, I'll just build it out now so they won't need to hit me up when they need something extra. So it's that kind of speculation, and that's mostly what I've seen.
Yeah. And how would you reuse your APIs as it gets expanded to multiple consumers? At what time do you think we need to spin up a new service rather than to add to existing service?
Yeah, I think it really depends on your product. I don't have like a really great answer to this. I think it really goes case by case. And I think as like maybe your domain really expands, or potentially like the API that you've initially built really doesn't reflect anymore what the business is doing. Basically, once it starts being really hard in terms of like maintaining it and kind of figuring out the schema, that probably about then.
Perfect. Thanks, Damir, for coming along and sharing your insights. Appreciate it.
Awesome. Thank you so much for having me.
Thank you.